Okay, we're going to start in on Chapter 8 today. So, Section 8.1 is dealing with the addition and subtraction formulas for sine and cosine. All right. So these are very straightforward formulas. I'll show you how they work. I'll show you how they're used. And then tomorrow we'll talk about actually using the tangent formula. So this first section, or the first part of the first section, is going to be pretty straightforward and not too difficult. So what we're talking about here is what happens if we're using multiple angles. For example, what happens if we want to look at sine of some angle S plus some angle T? And it turns out that we can actually expand this thing using the following identity. And that is that sine of S plus T is equal to the sine of the first angle S times the cosine of the second angle T plus, because this was plus, cosine of the first angle times sine of the second angle. So sine S cosine T plus cosine S sine T. So let's look at a quick example to see how that works numerically. Typically we'll use this with unit circle values. So for example, maybe we have sine of pi over 6 plus pi over 3. We want to know what that's equal to. Well, we can expand this out by taking the sine of the first angle times the cosine of the second angle plus the cosine of the first angle times the sine of the second angle. And now these are unit circle values, so we can just use our unit circle to actually evaluate these things, and then we'll simplify. Sine of pi over 6, sine of pi over 6 is 1/2. Cosine of pi over 3 is also 1/2. Cosine of pi over 6 is rad 3 over 2. Sine of pi over 3 is also rad 3 over 2. This obviously won't always happen. It's just the way I chose the numbers on this one that we see that. This becomes 1 over 4 plus square root of 3 times square root of 3 is 3 over 4, which gives us an answer of 4 over 4, which on this particular one is 1. Now, does that surprise us that we got an answer of 1? No, it shouldn't, because what is pi over 6 plus pi over 3? Well, that's pi over 6 plus 2 pi over 6 if we get a common denominator. That's 3 pi over 6, which is really pi over 2. And we know that sine of pi over 2 is equal to 1. So don't think that this is always going to come out equal to 1. This one happened to come out equal to 1 because of the angles S and T that I chose. And we'll see some other examples in just a moment. So that's how the sine addition formula works. Now, the sine subtraction formula, sine of some angle S minus some angle T, is equal to the sine of the first times the cosine of the second. And now, since this is a minus, this is a minus. Cosine of the first times sine of the second. And this is obviously going to work exactly the same way. And an example for this might be to find sine of pi over 12. Well, the problem is we want to find it exactly, by the way. Helps if I spell exactly correctly. We want to find it exactly, no decimals. Well, pi over 12 is not a unit circle value that we have memorized, but if we think about the unit circle values that we do have memorized, we know pi over 6, we know pi over 4, we know pi over 3, and I'll throw pi over 2 in for good measure. What we're going to do is we're going to change these all into this denominator, in this case 12. Pi over 6 is really 2 pi over 12. Pi over 4 is 3 pi over 12. Pi over 3 is 4 pi over 12. Pi over 6 is 6 pi over 12. What we need to do is figure out how to, in this case, subtract these, since we're going to use a subtraction formula. It could also be done with an addition formula, potentially. But we're going to do this with a subtraction formula. How can I subtract two of these angles to get pi over 12? Well, there's two ways to do it. Either pi over 4 minus pi over 6 gives us pi over 12, or pi over 3 minus pi over 4. I'm actually going to do this with pi over 3 minus pi over 4, so I'm going to use these two because when I subtract them, I get 1 pi over 12. So this becomes sine of 4 pi over 12 minus 3 pi over 12, which is really the sine of pi over 3 minus pi over 4. So this now expands into sine of the first angle cosine of the second angle minus cosine of the first sine of the second. We know that sine of pi over 3 is rad 3 over 2. We know cosine pi over 4 is rad 2 over 2. Minus 1/2 for cosine pi over 3, rad 2 over 2 for sine pi over 4. This becomes rad 6 over 4 minus rad 2 over 4. And since they have a common denominator, we'll go ahead and put these together into rad 6 minus rad 2 divided by 4, and there's our answer. Okay, so those are the sign addition and subtraction formulas. Now we have similar formulas for cosine, so we can do cosine of s plus t. And it turns out that cosine works a bit differently. It's cosine of the first and then cosine of the second. So the two cosines go together, and then the two sines go together. Sine of the first times sine of the second. What's a little bit more surprising, though, is what happens in between, and that is that since the original was a plus, we were adding s and t, the two angles. We're now going to have a minus in here. And we're not going to go through any derivation on this. This is just the identity, and it works for any angle s and t. So, for example, we may have cosine of pi over 6 plus pi over 3, where pi over 6 is your s, pi over 3 is your t. What I'd like to do is let's talk about cosine of 15 degrees. Actually, we'll do that with the, I take that back. We're going to do that with the subtraction formula. So let me give you the subtraction formula. The subtraction formula is just going to be cosine of s, cosine of t, plus the opposite of the minus here, sine s, sine t. And let's find cosine of 15 degrees exactly. So again, what we want to do is we want to rewrite cosine of 15 as cosine of two angles that we do know from the unit circle being subtracted. And for this particular one, let's use 45 degrees minus 30 degrees. That clearly gives us 15 degrees. You could also do 60 minus 45. That's essentially what we did on the sine one just a moment ago. So this is going to be equal to cosine of 45 degrees times cosine of 30 degrees plus, because that's a minus, sine of 45 degrees times sine of 30 degrees. Now we can evaluate these from our unit circle. That's rad 2 over 2, rad 3 over 2, rad 2 over 2, 1/2. This becomes rad 6 over 4 plus rad 2 over 4, which becomes rad 6 plus rad 2 divided by 4. Okay, very similar kind of answer to what we got just a moment ago on sine, except that there was a minus on the sine version. Here it's a plus when we do cosine of 15 degrees, also known as pi over 12. All right, so those are our sine and cosine addition formulas. And the assignment tonight is going to be pretty straightforward. There's not going to be anything fancy on it. You're going to be just looking at evaluating some of these different sine and cosine values with various angles. The other thing I do want to talk to you about, though, is how to not expand, but how to simplify one that has already been expanded. So, for example, they could give you something like this. They could say simplify, and they could ask you to do something like, let's say sine of 110 degrees times cosine of 10 degrees plus cosine of 110 degrees sine of 10 degrees. Well, we don't know 110, we don't know 10. Those aren't angles whose values we have memorized from the unit circle. But notice this is the structure of our sine s plus t formula, where s is our 110 and t is our 10. So this thing is really just equal to sine of s plus t. That now simplifies into sine of 120 degrees. And even though 110 and 10 were not unit circle values that we know, 120 is. So if you think about 120, which is up here at 2 pi over 3, the coordinates are negative 1/2 comma rad 3 over 2. So the sine value of this is going to be square root of 3 over 2. So even though we were using angles that we don't know from the unit circle, because of this formula, just using it in reverse, we can actually evaluate this thing exactly. Okay, so that's going to get you started on section 8.1. Tomorrow we will talk about the tangent formula, and we'll talk about some of the other kinds of problems that you're going to run into, and I'll give you some examples of how to do those.